Welcome to The Explainer. Today we're breaking down a fascinating paper from a team at Meta AI and KAUST that asks a really radical question. What if we just threw out 100 years of computer design? And we're not just talking about a smarter AI here. We're talking about a blueprint for a completely new kind of machine. So everything in this paper really boils down to this one huge question. Right now we think of AI as a program, right? It's software that runs on our laptops, on our phones. But this research, it flips that completely on its head. It imagines a future where the AI model isn't just using the computer, it is the computer. I mean, the whole thing, the operating system, the hardware, the screen you're looking at, all rolled into one single learning system. Okay, so here's how we're going to break this all down. We'll start with what this new kind of computer even is. Then we'll see how it's totally different from the hardware we're used to. We'll look at their early experiments, what actually worked. Then we'll get into the big, ambitious goal here, the CNC. And finally, we'll ask the big question, is this a whole new paradigm for computing? All right, first up, a new kind of computer. Let's get right into the basics. The researchers are proposing this brand new architecture they call the neural computer, or NC for short. And believe me, this isn't just a small tweak. It's a total rethink of what a computer even is. So here's the official definition, but let's break it down. Right now, the computer you're using has a bunch of separate parts, right? You've got your processor, your memory, your graphics card, all these distinct engineered components. A neural computer, it just throws all that out. It mashes all those functions, computation, memory, input, output, into one single learned system. The computer's entire state, what it's doing, what it's remembering, it's all just patterns inside the neural network itself. This is the key takeaway. The AI isn't just a program on the computer. The AI is the computer. Okay, so how do we really wrap our heads around this? The best way is to see it side by side with what we're all used to. Let's visualize the shift. And wow, this image from the paper really says it all, doesn't it? On the left, you've got your typical computer, a stack of separate, blocky hardware modules. But on the right, poof, all those distinct layers just kind of melt together into this one unified neural latent stack. You're literally going from a bunch of rigid separate parts to one big interconnected system. Here's another way to think about it. Your classical computer is like a team of specialists, right? You've got the processor, the memory expert, the graphics artist. They're all built separately and have to talk to each other. But a neural computer? That's more like a single holistic brain, where thinking, remembering, and seeing are all just different aspects of the same neural activity. It's totally interwoven. But look, this isn't just some sci-fi theory on a whiteboard. The team actually rolled up their sleeves and built early prototypes. They wanted to see if an AI could really learn how to be a computer just by watching one. So how on earth did they do that? Well, they used video models. They basically just fed these AI models tons and tons of screen recordings of people using a command line or a regular desktop. The whole idea was to see if the model could learn the rules of a computer, Like when I type this command, this text appears. When I click this icon, this window opens. And the real test was, could the AI then predict and generate the next frame of the video all by itself? Could it actually simulate the computer's response? So, the big question, did it actually work? Well, kinda. It showed a lot of promise. The prototypes were great at what the paper calls I/O alignment. In plain English, that just means if you type the letter A shows up on the screen. It could handle those simple, immediate cause and effect things. But, and this is a big but, it struggled with the hard stuff. Things like getting a math problem right every single time, or remembering a skill it learned an hour ago. That long-term memory and, rock-solid logic, it just wasn't there yet. Okay, so those early experiments are really just step one. They're basically a proof of concept pointing toward a much, much bigger goal. Let's talk about the long-term vision here. And that end goal has a name, the completely neural computer, or CNC. This is the holy grail. We're talking about a fully realized general-purpose machine, one that's stable, one you can teach new tricks without it forgetting the old ones, and one that can actually use those skills reliably whenever you need them. Now, to get from these early prototypes to a true CNC, the researchers laid out 4 big milestones. First, it's got to be turn complete. That's a fancy way of saying it has to be at least as powerful as a regular computer. Second, you have to be able to program it. Third, it needs to be consistent. It can't just randomly change how it works unless you specifically tell it to. And maybe most important of all, it has to actually be better in some way. It can't just be a cool science project. It needs to have real architectural advantages. So, yeah, this all sounds incredibly ambitious, right? Which leads to the obvious question. Why bother? What's the potential payoff here that makes this whole massive undertaking worthwhile? Well, if they pull this off, the advantages could be huge. Just imagine, programming your computer not by typing lines of code, but just by showing it what you want it to do. And on a hardware level, things could get way simpler. Instead of all these different data types and processors, everything could just be handled as tensors. That's the native language of AI. You could have one type of processor, one type of data. We're talking about a massively streamlined and maybe way more efficient system. And this quote from the paper it sums it all up perfectly. NCs are not a smarter layer on top of the existing stock, but a proposal to make the model itself the running computer. It's not about putting a new AI app on your desktop. It's about throwing the whole desktop out and replacing it and everything underneath it with the model itself. I mean, this is a truly radical idea, a complete break from how we've built computers for the last 100 years. And it leaves us with this one kind of mind-bending question to chew on. Will we one day program our computers just by showing them what to do? Are we about to start teaching our machines instead of just programming them? It's a wild thought. Thanks for joining us on The Explainer.